This is lesson 1.1a. In this lesson, we're going to be talking about solving equations. But for starters, we're going to talk about inverse operations. And inverse basically means opposite. So we're talking about opposite operations. So if we are talking about addition, the opposite operation for addition is subtraction. So basically, subtraction will undo addition, and addition will undo subtraction. So they're opposites of one another. We also have multiplication. And remember that in multiplication, sometimes it is written as a dot, sometimes it is written as a number glued to the outside of parentheses. And the opposite operation for multiplication is division. And sometimes division is written as a fraction. So as an example, A over B would be a fraction. Another one that we haven't talked probably too much about so far, if you have something like x squared, the inverse operation for x squared is to take the square root of that. So when we take the square root of x squared, we actually are going to get just x. So sometimes it's easy to recognize addition and sometimes it's not. So if we're looking at things to know, hey, this is addition, I'll need to use subtraction to undo that. We'd have things like x plus 3. That plus 3 part of it shows you that it's addition. But sometimes we have things like 3 minus 2x. In this instance, if I'm trying to undo and get x alone, I would have to undo the 3, which is positive because there's no sign in front of it. So in order to get rid of that 3, I would have to subtract it. In the same instance, with subtraction, the obvious one would be something like x minus 3. So you would recognize, oh, minus 3, to get rid of it, I would have to add 3. And then other times we'll have like negative 3 plus 2x. So again, in this situation, if I'm trying to get x alone, and I would have to get rid of this negative 3 by adding 3, making 0 essentially. And then sometimes when we're talking about multiplication, it would look like 3a, right? That's 3 times a. Or 3 times our parentheses 2, right? That's multiplication. Negative 4 times the quantity of x plus 5. I could undo that multiplication right here using division. And then one of the more obvious ones would be to use the dot. And so then that would be x times negative 0.75, for example. As we are continuing throughout the year, using an x for multiplication is not something that we're going to do because we're going to be working more with variables, and we definitely don't want to confuse a variable with multiplication. So make sure that if you're writing it, you're going to be using the dot or some kind of parentheses. If it's with a variable, then you can just glue it right to the outside of that variable to show that multiplication. All right, so when we are solving one-step equations and we're working with problems that have addition and subtraction, the first thing we're always going to do is undo addition or subtraction, depending on the problem, on the variable side. And it has to be the side with the variable, the side of the equation with the variable, because the goal when solving equations is to get the variable alone so we can figure out what its value is. So for example 1, if we have the problem x minus 3 equals negative 5, we're recognizing that this is a subtraction problem, and we talked about how to undo subtraction is to use addition. So we're going to add 3 to both sides. We have to keep it balanced. Now I draw this line to show the two sides of the equation so I don't accidentally put plus 3 on the same side multiple times. And then I'm going to simplify. So negative 3 plus 3 makes 0. So I'm left with x plus 0, or just x. And then negative 5 plus 3 gives us negative 2. So then I'm going to carry it down here. X equals negative 2. Now, sometimes you're going to be asked to justify how did we get here. The first way that we justify is always that we write the equation. Then this step that we did here, we used what's called the addition property of equality. So I'm going to abbreviate it with add instead of addition. So addition property of equality. And then from here to here, all we did was simplify. So if you're asked to justify your steps, that's essentially what you're being asked to do. We wrote the equation, we used the addition property of equality, and then we simplified. For example 2, we have 0.9 equals y plus 2.8. Now, off to the side here, I'm going to show you, some people, when they see this, it gets very confusing. So if you're somebody who prefers it written this way, with the variable and the number on the left side of the equal sign, you can write it as y plus 2.8 equals 0.9. It's going to give you the exact same answer, excuse me, but it's just another way to write it. So again, draw my line down the equal sign. Now this one I notice is an addition problem. So in order to undo that addition, I'm going to have to subtract. And I always want to subtract the number that is keeping the variable from being alone. So minus 2.8. So 2.8 minus 2.8 gives us 0. So we're left with y on this side. 0.9 minus 2.8 leaves us with negative 1.9. Now, most of these first steps, if we're justifying, are the same. So for example, write the equation. The last step down here is simplify. That was the same. The one thing that's different for this one is this middle step, and this one is the subtraction property of equality. Sometimes we're dealing with multiplication and division. So when we're dealing with multiplication and division, we're going to undo multiplication or division, depending on what you're dealing with, on the variable side. So for example 3, we have negative n over 5 equals negative 3. So we've written our equation. Now what we're noticing is it's negative n over 5. Fractions are division. So in order to undo our division, we're going to have to multiply both sides, and we're going to multiply by what was divided. So I am going to keep the negative sign when I'm multiplying. So I'm going to multiply both sides by negative 5. All right, so if we cross cancel -5 and 5, those will cancel out to make 1. So we have -1 times -1n. Lazy mathematicians, they don't like to write it if they don't have to, but it is -1n right there. Excuse me. So -1 times -1 is 1. And if we made this a fraction, 1 times 1 is 1n. And then -3 times -5 is +15. So n equals 15. Again, if we're justifying this, we're going to write the equation. This step right here is the, I bet you can't guess, multiplication property of equality. I'll just do prop for abbreviating it. And then the last is to simplify. All right, so example 4. We have pi x equals -2 pi. Draw my line. This is multiplication, keeping that x from being alone. So we're going to undo that by dividing both sides by pi. And I would suggest writing your division as a fraction, because in some instances, that's going to make life so much easier, because you'll just be able to simplify your fraction and be done with it instead of having to actually do a lot of division. So pi divided by pi is 1x. -2 pi divided by pi, those pi's will cancel. That leaves us with -2. So we wrote our equation. And then this step here is the division property of equality. And then last step, we simplified. Sometimes we'll have division, but it won't look exactly the same. So for example, this one, we're using a decimal instead of pi. So 1.3z equals 5.2. It's still multiplication. I'm going to divide, but this time I'm going to divide by 1.3. So sometimes we get tricked up over here because we're dividing by pi, but this one we're actually going to divide by 1.3. 1.3 divided by 1.3 is 1z. 5.2 divided by 1.3 is 4. And this has the same division property of equality that we had in example 4. And then last, example 6. If we have -3/4 n equals -2. So when I'm looking at this, -3/4 times n, automatically I think, okay, it's multiplication. To undo multiplication, I have to divide. True. When I'm dividing fractions, so this is the number that is getting divided, so n can be alone. So it's like -3/4 divided by -3/4. When we divide fractions, we keep the first fraction, -3/4, change division to multiplication, and then we flip that last fraction to become -4/3. So keep, change, flip. So instead of showing this whole bit every single time, I'm just going to take the part right here that shows I am multiplying by -4/3, and I'm going to do that on both sides of the equal sign. So times -4/3 times -4/3. I'm going to make the 2 into a fraction to make life easier. So cross canceling, those 4's become 1, 3's become 1. So I have 1 over 1n equals negative 2 times negative 4 is positive 8. 1 times 3 is 3. So n equals 8/3. Perfectly acceptable answer. Sometimes you're asked to make it into a mixed number. So if we're making it into a mixed number, 3 goes into 8 2 whole times with 2/3 left over. This is lesson 1.1b. One of the things that you're going to have for this lesson is a sheet that says words and phrases to math symbols. So inside the symbol, it gives you different words and phrases that remind you that, hey, these ones are about addition. These are about subtraction, multiplication, and division. These are signal words for equal sign, and these are signal words for parentheses. Now remember that these aren't the only words that you're ever going to see. There are others that you could see as well. So as you're going through questions, if you find that there are some that you commonly forget or you make mistakes with, feel free to add them on. I mean, you could even section it into boxes so that you have each one in its own box and then add to that box as you find more words. So as we're going through, example 1, in the 2016 Olympics, Usain Bolt won the 200-meter dash with a time of 19.78 seconds. Find his average speed to the nearest hundredth of a meter per second. So a couple things we want to look for. Some important pieces of information. So he had a time of 19.78 seconds. We're looking, here's another one. He ran the 200-meter dash, so that's his distance that he ran. And they're asking you to find his average speed. So keeping these things in mind, one of the equations that we're going to need to know for this is called the distance formula. So, for example 1, we're going to write down the distance formula. So, distance equals rate times the time. And this is a common formula that's used to find distance in many different areas. Obviously, we're using it for math. Use it in science for different things. So this is one that you're going to want to keep in your mind. Often, we just use the variables. So we'll do D equals RT, knowing that RT means rate times the time. So we're going to go back to our example where we underlined things. When we were underlining, the distance that we underlined was blue, and that was 200 meters. So we're going to plug in 200 there. The rate is actually what we're looking for, that rate of speed, his average speed. So we don't know the rate yet, but we did use this orange color to show that average rate of speed. Times his time, which is 19.78 seconds. Now, you can leave it just like this, or you can rewrite it so that it is 19.78 times R. Both mean exactly the same thing. Some people find it easier to solve when it looks like this. Other people, this doesn't bother them. It's your choice. Whatever one makes the most sense to you, I want you to do that every time. So now that we have our formula figured out, we're going to solve for R. So since this is multiplication, we're going to undo that multiplication using division. Excuse me. And we're going to divide both sides by 19.78. So once we do that, this cancels to be 1R or just R. Either way is fine. And then 200 divided by 19.78 is 10.1112, and then there's more decimals to follow. But they asked us in the example, round it to the nearest hundredth of a meter. So remember, if I'm rounding to the hundredths place, right, here's our hundredths, we have to look at the number just after that to decide what to do. So this one makes that one stay a 1. So we've got 10.11 equals R. So in other words, his average rate, or his average speed, I'm going to use AVG for average, is about 10.11 meters per second. And then we're going to move on to example 2. So for example 2, in 2015, an autonomous vehicle drove from the Golden Gate Bridge to New York City at an average speed of 15.7 miles per hour. The journey took 9 days. About how far did the vehicle travel? So in this case, we're looking for how far did the vehicle travel. So we're looking for the distance. They told us that the average speed was 15.7 miles per hour. And they told us the time. It took 9 days. So we're going to calculate that into our equation. So we're writing our equation. We're looking for the distance. So we're still using that distance formula, D equals RT. We are looking to find the distance this time. So D equals the rate, remember, 15.7 miles per hour. Times the time. Now what I want you to look at is our rate is talking about miles per hour. The time we're given is in days. So we need to think about, if it's 9 days, how many hours would that become? So I have 9 days times 24 hours each day, and that's going to give us 216 hours. The 216 is what I need to calculate into my formula here, because my rate is based on hours, not days. So I need to make sure that I'm calculating the hours for this formula. And then this one, I just get to multiply. There's no solving otherwise to do. I'm basically just simplifying. So this distance equals 15.7 times 216 gives us 3,391.2 miles for our total trip. Well, for that vehicle's total trip. And then example 3. Example 3 says, on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees Fahrenheit at 9:27 a.m., how many degrees did the temperature fall? So it fell from 54 to -4. So we are looking at -4 is where we're ending up, and we want to know how we got there. So the other important things fell from 54 degrees. And we want to know how many degrees did the temperature fall. So we're going from 54 to -4. Just slide that up a little bit. There we go. All right, so we've got -4. That's where we're at. Equals 54 degrees. So it was at 54 degrees. And then it fell. So fell tells us that it's subtracting some temperature. We'll call it T for temperature. You could use any variable. It doesn't matter. I'm just going to use T because it reminds me that it's temperature. In this instance, the time, 9:27, doesn't play anything into this. The date, fun factual information, but it doesn't play into my actual equation. So from here, I'm going to solve. So I'm going to start by subtracting 54 from both sides. So this makes 0. And then -4 minus 54 gives us -58. So if I simplify this up, I have -58 equals -T. Now, if we're thinking about it, negative sometimes means, or always means, the opposite of whatever follows it. So do I want to know what the opposite of the temperature is, or do I want to know what that temperature is? I want to know what the temperature is. So in order to get rid of my negative, I'm going to divide both sides by -1. And all that's doing is essentially making this negative T become just T, because that's what I want. That's what I'm solving for. It's just plain old T. So T equals -58 divided by -1 is +58. So for this question, to answer what they're asking, how many degrees did the temperature fall? Temperature fell 58 degrees. And we can use the Fahrenheit because that's what they were talking about, was 58 degrees Fahrenheit.